Hello, everybody. Today we are talking about the work energy and connection in motion. So, first connection is units. Units is joules, and joule is um, joules is newtons times meters. So that's our new unit over here, and it's same for work and it's same for kinetic energy. For us, it's important to find that connection between work and kinetic energy. So, first thing that I've have written over here, it's that after some applied force, we can see the change in the distance. Let's do some example over here about that. Let's go over here, for example. And then we have the force, and there is some type of change in the distance. Of course, this needs to be a little bit more accurate, but that is um, just for you to imagine it. So we can have this box in the different position 1 and position 2, and that displacement, since this might be a reference point 0, it can be like 10 meters, for example. That's the first thing. But and also, I just want to tell you in advance. This is just because when we have the angle, this formula is functioning when we have the angle of 0. Because if we are pushing that box under some angle, the problem becomes more complicated. And that's why we are just looking at the situation when the angle is 0, because this has additional part, cosine of the angle times cosine of the angle, but cosine of 0 equals to 1, so it doesn't affect anything on the formula for now. But we need to know that the angle is 0 when we are pushing the box. So, okay, so I have explained you that part, but let's look at the formulas and how we do actually find that connection and similarity between work and kinetic energy. Okay, so we know that work equals to the force times distance, and we know the force equals is directly proportional with the mass and acceleration. So we can see that here. After that, we were using the formula for initial and final velocity because we know that kinetic energy is 1 hour mass times 1/2 times mass times the velocity. So to get to that part, we need to kind of use velocity to prove that those two formulas are same. That's why we are bringing this formula. Okay, and we are going to try to get just this part, a times d, and we got it here. What we were doing with this formula, how that appeared to be this, because we would put this over here and it's going to be minus v0 squared, and then we would just divide it by 2 so we can get rid of this part. I hope I'm making it clear. And then we got this. We have 8d part in our formula, so we would just put this over here. Okay, I already typed everything, so I can just make it simpler for you. And then here we can say that the work is equal to the change of kinetic energy. What that means, work equals to, what is change? Change is final and initial, like subtraction of final and initial. So we have the final kinetic energy and we have initial kinetic energy. Those small coefficients are representing them. Final, this F for final, and then this 0 for initial. I'm just making sure that you understand every part of this presentation. So that's how we got to the changing kinetic energy. And let's see our work done. How we can represent work done now. So since we know that kinetic energy is 1 over 2 times m times v squared times mass times velocity, we can say final velocity over here, and we can say initial velocity. Okay, we have that. And that's we have that type of that shape of the formula. Now we wanted to make it similar, almost same. So then that's why we divided 1 over 2 times m times final velocity squared minus 1 over 2 times m times initial velocity squared. So we can see that those two are actually same. If you take a better look, you can see that they are same. And I'm about to help you also with doing this. Now you can see the similarity between this and this. I hope that's clear. And if it's not clear, we are going to make it clear by one example. What can be better than example? Okay, so let's do it. Here, I made an example. So we're going to think that we have a box of 2 kilograms, okay? And we have force that is applied on this box, and it's force equals to 2 newtons. Force, we know how we say force here. And we have initial velocity that equals to 1 meter squared, 1 meter per second, I'm sorry. Velocity can be meters squared. Okay, so after that, this box was moved for 10 meters. So our distance or displacement is 10 meters. Okay, so let's see if we were just going the simplest way. What is force? What is work? We have 2 newtons times 10 meters, which would be 20 joules. Okay, let me just change the color so we can actually see all of these small parts. Okay, F here, and then we have 20 joules. We will just go with this part. Okay, yes, I like that. Okay, so let's go back to the pencil. Okay, now let's see how we're going to find the kinetic energy. Let's talk about the formula for kinetic energy. That would be over here. Work equals 1 over 2 m v0 squared, v final squared, sorry, v final squared, minus 1 over 2 m v0 squared. Okay. Okay. So we don't have the final velocity. So let's find the final velocity. What is our formula for final velocity? Initial velocity plus 2 times a times d. Now we understand that we don't have a, or differently called acceleration. So what is acceleration? We know that, okay, let me do it here. We know that force equals to a times d. I'm sorry, force equals to directly proportional to mass times acceleration, okay? So let's try to find acceleration, F over m. And in this case, that would be 2 Newton over 2 kilograms, which equals to 1 meters per second squared, okay? So let's plug that all in to this formula. I hope we are making some type of sense. So it would be Vf squared, or final velocity squared, equals to initial velocity, which is 1 meter squared, 1 meter per second, plus of that squared, plus 2 times 1 meters per second squared times 10 meters. Okay, that would be 21. And I'm going to keep it meters per second, squares per second. I'm going to keep it in that form because I'm going to use it in that form over here. Okay, so we don't need to have some additional steps. So let's see. Okay, V equals 1 over 2 times 2 times 21 minus 1 over 2 times 2 times 1, and V equals 21 joules minus 1 joule, which equal to 20 joules. The same answers that we got just by using the work and using the kinetic energy. Thank you for watching. I hope you understand it.